Institute Distinguished Lecture. Today we are pleased to have Bongshin Lee, who is a senior researcher at Microsoft Research. She explores innovative ways for people to create visualizations, interact with data, and share data-driven stories, which is the theme of her distinguished lecture today. So Bongshin currently serves as the general co-chair for the IEEE Pacific Viz 2017 conference. She's also an associate editor for the IEEE Transactions on Visualization and Computer Graphics, and she was the paper's co-chair for InfoViz 2015 and 16. She comes to us previously as a PhD in computer science from the University of Maryland at College Park. Do you work with Ben or Catherine or both?
No, Ben Peterson.
Okay, all right. Oh, okay, right, all right. A different Ben. So we had the other Ben here last year. All right, so please join me in welcoming Bongshin to the University of Utah.
Thanks, Chris. Thanks all for coming to my talk. It's my great pleasure to share a short story about my recent research on data-driven storytelling today. As Chris introduced, I'm a senior researcher at Microsoft Research, which was founded in 1991. We had 25th anniversary last year. We have more than 1,000 scientists and engineers worldwide, and we strive to make technical innovations and advance the state-of-art computing. My main research area is human-computer interaction with the focuses on information visualization. And recently, I've been working on these 4 topics: human-centered machine learning, natural interactions for InfoViz, personal data visualization and self-monitoring, and data-driven storytelling. So even though I put these things into these nice 4 boxes to mimic Microsoft logo, they are not mutually exclusive. For example, my very first project about data-driven storytelling was leveraging pen and touch interaction for more engaging presentation. And I'm also trying to apply data-driven storytelling to personal data visualization and human-centered machine learning. So across all 4 topics, what I do is I explore innovative ways to help people not only just understand, but also communicate their data with people. Here is the list of my visualization-related project I did over the last few years. Don't worry, I know that I have less than an hour, so I'm going to talk about just these 3 projects in the opposite order. So after I did my very first data-driven storytelling project, I soon realized that this storytelling is a very overloaded term. And I couldn't find any crisp definition of a visual data story. Also, I couldn't find any meaningful discussion or description of the storytelling process. So what I did is, with my dear colleagues, Natalie, Petra, and Sheila, I decided to take a look at how visualization community has discussed storytelling. And after having many meetings and heated discussions, and after reading many papers and articles, we decided to write this visualization viewpoint article, basically arguing for narrowing the scope of visual data story, but for widening the research on storytelling to cover the entire process of transforming data into visually shared stories. So unfortunately, we couldn't manage to come up with a one nice, one sentence definition of a visual data-driven story. So we proposed visual data-driven story to be like follows. So a visual data story includes a set of story pieces that is specific facts, but backed up by data. So for example, how energy consumption has changed over the years. And then most of these story pieces are visualized to support the intended messages. And visualization here include annotations and narrations to clarify points and insights that they want to convey. Lastly, these story pieces are presented with a meaningful order or connection between them, again, to support the presenter's high-level goal, which includes entertaining, educating, or convincing the viewer. So with this narrow scope of visual data-driven story in mind, by the way, because visual data-driven story is a kind of mouthful, so during the talk, I'm going to say either data story, visual story, or data-driven story. They all mean this visual data-driven story. So when we looked at visualization research on storytelling, we realized that most of them actually focuses on how visualization components can contribute to communicate data, but nothing much on the process itself. So we proposed this storytelling process as a working model, which consists of these three phases. And we also identified different roles and the activities that these data storytellers engage in, along with types of artifacts they create throughout this process. And we also discussed external factors like settings and medium that also affects the entire process. It's all nice, but one main weakness of this process is that it's not really grounded by any empirical data, even though we looked up other models in the data journalism literature. And then I attended this Dr. seminar on data-driven storytelling last year and joined the group writing a book chapter on process and tools to support the life cycle of a story with this many people. And to overcome that limitation, we interviewed 9 data storytellers during and after the Dr. seminar. And then we revised our storytelling process. Thankfully, it was not like fully wrong. We just missed a few things. For example, we learned that there are other roles like data collector or director and producer who basically provide the money to create the story. And there are other external factors in real life, such as ethics, legal issues, and time and cost. So we expanded this process. Okay, so now I'm going to switch gears a little bit and talk about my other efforts in enabling people to create this nice data story. So over the last few years, with many other collaborators, I designed and developed several data presentation authoring tools, and they cover different media, such as data videos, chart images, or slideshow style presentation. And they also cover different settings, like live presentation versus asynchronous story consumption. And I'm going to talk about these 2 very recent projects. And these are not presented yet in the conference, so it's really, really new. So chart text and paper will be presented in Pacific Biz in 2 months. And this timeline storyteller will be presented at Biz this October. Okay, so let me start with chart text. And this is the collaboration between UC Santa Barbara, Penn State University, and Microsoft Research. So it's helping people to create annotation for data-driven storytelling. So annotation is super important in storytelling. So Amanda Cox, a graphics editor at the New York Times, once said, the annotation layer is the most important thing we do. Otherwise, it's a case of, here it is, you go figure it out. Yet, current existing charting tools have very limited annotation support. So many people, including me, end up doing this. So we export chart into the authoring tool like PowerPoint or Illustrator as an image, and we annotate those charts using the features from those tools. And this is not just for lay people. For example, in 2015, this Gregor Ice, another graphics editor at the New York Times, wrote this blog article summarizing his lightning talk at the NICAR conference. 7 features you will want in your next charting tool. And I'm going to show you just 3 of the simple ones. By the way, I downloaded this from this website. The first one is just direct selection of data points from the chart, and then it does annotation for you. The second one is inline text editing. So for the edit label, he just want to edit from the chart. The third one is related to the second one. He just want to add some text to the chart. So, but that's what he needs from next charting tool, meaning that current tools do not really support. So we create this tool called Chart Accent, and I'm going to show you a brief demo. So trying to mimic this chart here. So highlighting the bars of the Seattle and Charlotte that's above the New York's average. Let's see. Here we go. So here's the chart. Let me just. First of all, I can just click on the axis, and then I can use this one. Say I can choose what's above this line, and it's do this, and I don't need all the labels, and it's all then that. So if I move, then it does automatically update the one, and instead of using fixed number, I'm going to use average of New York, which happen to be, and then I can update the text here. I'm going to move this thing to here and just highlight this. And again, doing X. So with some clicks and typing, I recreated the one. Someone with a good eye could have noticed that actually other bars are not unhighlighted, and I can do that by selecting them all, doing this, and then move this, and send that thing to back. So I now have a very nice unhighlighting of all other bars, but highlighting the bars that I wanted. I'm going to show you another one just to cover other features that I have. So we allow people to select the series by interacting with the labels. And then when multiple items are selected in the scatter plot, we can provide the bubbles chart. It's kind of light, but you see, and in fact, I can make it real red. You wouldn't do in I hope you wouldn't do in real life, but that's what I wanted to show. Okay, so I hope you got some idea about what chart accent does. Let me go back to the slide and let me explain how we designed chart accent. So in fact, this chart accent project was inspired by my other previous work. So in an effort to characterizing these visualization insights from that visualization insights that people value, we analyzed 30 video recordings of the quantified self presentations. So for those people who don't know what quantified self is, there are this group of people who are very enthusiastic about collecting the data about themselves to improve their lives. And what they do is they have these meetup talks, and they share their self-tracking practice. And this talk has very nice structure. And one of them they are supposed to talk about is that what they learned from the data they collected. And while they're doing it, remember this chart? So they use lots of annotations. So we analyze these charts that people used in their talk, and then identified 7 annotation types these people use, like label, shape, trend line, image, etc. So that's how it was inspired. But then, to validate and revise and build upon this analysis, we surveyed additional more than 100 annotated charts from journalistic media, from Wall Street Journal, Economist, etc. So the main difference between this data set and the previous one is that these charts are designed for a broad range of audience, and it's also designed professionally for asynchronous consumption. But interestingly enough, we didn't find really anything new annotation types from this one. So from these 2 analyses, we identified the design space for the annotation in the context of data-driven storytelling, which is very simple: annotation target and then annotation form. So you choose the target and you annotate. That's what I did during my demo as well. So let me just go over some annotation target types. So here, the simplest one is just the data point. I go click, and then I add label annotation. Other thing is set of items that I manually select. Another is the set, but defined by some other values. So I can select the data points that's below this temperature, freezing point. That's we call coordinate target types, because it's a basic data series and set. And the second one is going to be the coordinate target types. So here, as I showed you, you can draw the horizontal reference line derived from the data value or just a fixed value. And it can be done the same way across the x-axis to specify the region from March to May, to specify that it's spring. So for these target types, once you select them, then you can annotate. So simple shapes and text, image, and then highlight. Another example here that's using this is so arrow, shape, text, and images, and highlight. One thing to note is that one target can be annotated using multiple forms. So for example, the United States here, highlighted, has a label, and then image as well. And that was also part of this bubble set as well. Guess what? So after we designed the system, we did usability study to evaluate the experience of annotating chart with chart accent. So we recruited 11 participants with very diverse occupations, including receptionist and real estate broker, because we were so confident that anyone can use this system, which was a little bit of an issue. And we followed very typical lab study procedure. So we started with a brief introduction and pre-study survey, and we gave tutorial to explain what chart accent is, etc. And we asked them to perform 12 practice tasks and then do the 7 real-timed tasks. And after they complete the task, we did a short debriefing and then post-study questionnaire. So this is the study setup, and we provided a target annotated chart as a task on the left screen and asked them to reproduce the same annotation using chart accent on the right monitor. And then this is the first 6 tasks that we tested. And we chose these tasks to cover most of the chart accent capability, but also the diverse target types and annotation forms here as well. And as you may guess, we increase the difficulty and complexity as the task progresses. So task 6 is a lot more complex than task 1, which is just selecting some items and then move the label around. And the 7th task was the demo I showed you. And this figure, which was generated with chart accent, shows the task completion time by participant and by task. So x-axis is the task time, y-axis is the task. And this P9, who is a software engineer, performed real well. So she did almost all tasks the fastest. And the average time across all participants and all tasks was less than 2 minutes, which is very good, I think. And these two longest ones was because of one of the main usability issues, which was, at that time, we did not support G-order. So if they forgot to unhighlight the one before they add on other annotations, they had to redo from scratch. So it took a while for those people. And we asked people to rate chart accent for 4 questionnaires, satisfaction questionnaire. And as you can see, people indicated that they enjoyed this annotation practice, and they also expressed a very strong desire to use chart accent in the future if they need to annotate chart. 6.9 out of 7, which is pretty good. So after the usability study, we fixed the major usability issues, which was, we didn't support undo and redo initially. So now it supports undo and redo, G-order manipulation, etc. And other thing is also to enable people to annotate their chart, their own chart. We incorporated a very simple chart creation mechanism and then deployed it on the web. So we announced it using Twitter 2 days ago on Wednesday. So you guys, if you need to create some chart, go try and then give us feedback. That would be great. So in summary, here's what we did. We analyzed the existing annotated charts and we identified the design space. We created a charting tool and then evaluate the system and made it available. So now we are collecting people's usage data as well as the chart, annotated charts that they create. Okay. Any questions? Okay, good. So, No, right now we support only 3 chart types, bar chart, line chart, and scatter plot. And when we did the study, we had our own fixed web environment for the study, which just loads the chart that we created before. Right now, because we incorporated the chart creation, you can upload your own data and then create for those 3 charts. And extending it to other chart types is future work. So when we recruit these people, the recruitment criteria is that anyone who has created a chart, I think within the last 3 months, but we didn't require them to annotate any chart. So if they created a chart with Excel, they could have come. And in fact, when we brought these people, we soon realized that these people are not really tech savvy. So they have trouble, like they didn't know what Control A means, like select all. And they also some people couldn't do marquee selection, like dragging and then select items, or like Control click or Shift click to select multiple items. So we have to even teach those things to these people. But some had some experience and they expressed the comparison against the existing one. So one guy actually was creating a chart using R. So, and he explained why it's better than the other one. Mm-hmm. No, we didn't test those. And that's one of the things that we want to learn from this deployment study, that what kind of annotations people do. We don't have that information yet. But there's a little bit of chicken and egg problem in that they can create the annotation that we provide, so it cannot go really wild, but hopefully if they want other types of annotation, they give us feedback. I want to create this, could you support this? So those things we want to collect through this deployment study as well. Okay, I'm going to go to the next project, Timeline Storyteller. And this project actually started summer of 2015 as Matt Bremer's intern project, but it's a collaboration between Microsoft Research and University of British Columbia. You see the Tamara at the bottom, who was Matt's advisor. So before I continue, let me clarify what I mean by a timeline. So a timeline can show a sequence of events, like the one in this table. And these events can have duration, and it has texture or categorical description. Another, I want to make a contrast against another confusing thing, the timeline, the quantitative time series data, like this daily temperature values. And today, I'm talking about the former, the categorical events data, not numerical time series data, which can be visualized using bar chart or line chart. So I'm going to show you a short demo here. I created this real kick last night, so it's probably not super interesting, but say this is my publication timeline. So you see that I started publishing something from 2002 from my very first internship. And then, look, I was very prolific in 2012. Now let's look at all of my publications by all different venues. I go to I submit papers to all these many conferences covering lots of different things. Yeah, I have a very broad research interest. Now let's look at only the Chi papers that I published. So, and here you go. This is my, oh, I'm not supposed to do this. Anyway, because I had it here in my story. So my first Chi paper was in 2003. It was about electronic voting, which was my independent study project with my advisor, Ben Biderson. Okay. And now let's compare it against TVCG, which is combination of regular TVCG and InfoBiz papers published as TVCG and best papers published as TVCG. And my very first TVCG paper was from my dissertation. It's called 3+. Okay. That's end of the demo. So these timelines can communicate a number of different aspects of event sequences. So what I want to emphasize in my talk today is that some timeline design choices are better than others for communicating these different aspects, such as chronology, category, distribution, sequence, periodicity, or synchronicity. Let's now go back in time 2.5 centuries and consider this diagram drawn by Joseph Priestley in 1765. So it's linear, and it reads left to right, having a chronological scale. And this labeled line represents a lifespan of one famous philosopher or politician. And the vertical axis bear no meaning here. They just stack them to avoid occlusion. So many of the contemporary timelines actually have some resemblance to this Priestley's design. However, despite its popularity, this is not the only way to draw a timeline. So to identify the design choices that go into making these timelines, we surveyed a large number of timelines and timeline visualization tools. And there were 4 categories. The first was timelines or chronologies curated by historian. The second one is contemporary infographics and data-specific bespoke timelines. The third category was visualization tools for exploratory data analysis. The last one is interactive timeline authoring tool. By the way, the one I'm showing here is a very small fraction of this large data set, 263 timelines we surveyed. So after collecting and analyzing all these timelines, we arrived at these 3 dimensions to describe timeline. The visual representation such as linear, radial, or spiral, and the scale of a timeline such as a chronological scale, logarithmic scale, and sequential scale, and finally, the layout of the timeline, one timeline or multiple timelines in a single display. So let me step through some design choices using examples from the survey. So here comes the radial representation. It's an infographic showing the 24-hour daily routine of several creative people. And on the right side, I've enlarged the one for Mozart. So it's showing the midnight at the top and noon at the bottom. And it's using color to encode different activities. So sleep is white and composing is green here. So these radial timelines work well when you want to convey the cycling pattern, like every day Mozart went through this thing. Maybe not exactly the same time, but that's the pattern that this one wants to convey. The second one is a grid presentation. So on the left, what you see is the Peabody's Polish-American system of chronology. So in this 10 by 10 grid, each row represents 1 decade, and one cell represents 1 year. And within each cell, color and shape represent different types of events. And another grid representation we are all very familiar with is the common calendar. But what's interesting is that we don't really find many examples in visualization systems, the calendar timeline. Another is the curve representation. So on the left is this drawing by Mark Twain. So, and he was arguing that using this kind of drawing can help people remember the history dates better. That was his argument. And on the right side is the timeline of the Arab Spring. So these things are often very playful, and this reminds probably you of the board games. You see many of these sequential timeline style, the curve representation. Okay, I'm going to now talk about some scales, so relative time scale. So in this example, from first published to masterpieces, the infographic, it's showing the life of some books from the modern library ranking. So each circle represents one person's lifespan, and the top, each triangle, here the top is the birth of the author, and one corner is when this author published a book, and the last one is the death of the author. So you can see that Joseph Conrad published first book on 38 and published some until 50 and died at 67. So because it's not showing the publication time chronologically, but relative to the author's age, you can compare these different authors who lived in different times. So some are more young genius versus others are late bloomers when you look at these things. Okay. The next one is the sequential timeline. So it's showing the evolution of coins throughout history. So the sequential timeline, it ignores chronology, but just focus on the sequence. So it's showing whenever the new coin was introduced. And you don't really know how long they lasted unless you read the labels carefully. And we saw the facet layout already. So in this Joseph Priestley's design, he in fact showed two types of occupations using the facet. The top one was representing man of learning. The bottom one was statesman. And the segmented layout, as the name implies, you segment one time using some division of time. So in this case, this example is showing the average American person's life. So from top to bottom, and each row represents a year-long segment with the 52 weeks. And now it's showing the frequency of all these different design choices. And not so surprisingly, the simple ones like linear representation, chronological, and unified layout were most common. But this curve layout and then relative scale and facet layout were also reasonably common as well. And we also looked at various design combinations. So given 5 visual representation and 5 scale and 4 layouts, there are 100, 5 times 5 times 4, 100 possible design combinations. But from our survey, we identified only 26 unique combinations there. But then when we evaluated all these ones based on whether it's generalizable to other timeline data sets or it's interpretable or if its purpose is clearly identifiable, it reduced to 18. And then using our own tool, we tried out some different combinations and then identified 2 that we didn't find in the survey. So ended up with 20 viable design combinations. So the gallery of these all 20 viable design combinations are available on our project website, and they are all implemented in this timeline storyteller I showed you before. So you may have noticed that right now it's showing authoring environment with all the 3 dimensions at the top and some toolbars on the left side. So this one is also publicly available. We are sort of doing the remote usability study, but if you guys want, go play with it and provide with us some feedback. So I have very similar summary here. We surveyed 263 timelines and identified 3 design dimensions to describe timeline storytelling and identified 20 viable combinations and then created a timeline storytelling tool based on all these analysis. And here's the URL and email. Okay, so I'm going to talk briefly about the future research directions I believe super exciting and challenging as well. So the first one is to support the entire life cycle of the story. Seamless integration from exploration to presentation. You might have noticed that even after I presented this nice storytelling process, the projects I ended up showing is all the tell a story side. There is a big missing hole in make a story part. And then combining all these three different phases is a big challenge. And oftentimes, as I showed you, it involves different roles and different people. So supporting them collaborate well is another challenge here. The second one, so evaluation is difficult for visualization, period. But evaluation is even more difficult for visualization for storytelling. Partly because we have at least two parties of users. One is the author and presenter who is going to use these tools. The other is the audience. So not only the tool, but also these stories need to be evaluated. But we don't even have a good metric to measure what's engaging, what's interesting, what's compelling, etc. So it's a very, very challenging research problem. The third one is visualization literacy. So the visualization community so far targeted these experts, like scientists, biologists, etc. But with the storytelling, it's for a broad range of people who may not have good visualization literacy. So you need to make sure that your story could be understood by all these people. Another interesting aspect about visualization literacy is that it's bidirectional, in the sense that, in fact, you could use data-driven storytelling to improve visualization literacy. The last but not least is coming up with novel and engaging experiences. So we are witnessing this rapid advancement in technology, all these AR, VR, MR, and mobile phones and tablets, etc. So it would be interesting to come up with new and more engaging way of telling the story and consuming the story. Okay? I'd like to thank my dear colleagues and thank you all for listening, and I'll be happy to answer any questions you may have.
That was great. We have time for questions. More questions? Yes, Magdalena.
Probably we did, but I don't remember. And I don't know what's too much. So there are cases that they had lots of annotations. In fact, in my own paper, I have a figure with many annotations because I wanted to show all these different targets, and I ran out of space, so ended up putting, 10 or 11 annotations, and I didn't use that figure in this presentation. I split them into multiple ones.
One of the things that we talked about in our research group is this interesting shift that we've seen in this group 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 data-driven story types of things a lot with interaction and scrolling, and that I think you make a statement that 2014 you felt was like the highlight. Yeah, that was the best year of storytelling. Right, and that since then, our suspicion is because they're moving towards mobile, where you don't have to. So I'm just wondering what your thoughts are on this sort of trend that is making new organizations moving away from some of the more advanced features. What that means for the bigger space of data-driven stories. Are we going to see less interaction, or are these sorts of innovative ideas going to come from different parts of media or something?
So, it's just my guess, but I think eventually these more engaging and interesting experiences will come because these devices will get just better. It's not going to be worse. And in fact, even though New York Times gave up on these steppers and they downsized those things, but we see new things as well. So now there's a mobile story that use VR or AR thing to give more engaging experience. And again, this whole VR AR is going to be cheaper and get better, etc. So I bet that in the future, we will see a lot more new stuff, and I hope as well. Hmm? Yeah. So in fact, I'm from University of Maryland, where Ben Schneiderman was like in HCIL, and I remember my assignment or midterm exam, take-home exam, either midterm or final, and the topic was comparing 2D viz versus 3D, and I know what Ben thinks about those, and I sort of agree with him, and so I'm one of those people who are very cautiously skeptical about doing InfoBiz with 3D. And I also worked with George Robertson for a long time, and he was real advocate for 3D, and he more or less gave up, in my opinion. But I think that this VR, AR, and storytelling might be a good candidate for using InfoBiz for storytelling. So because we could provide like narrations and additional information and guide people to go through the story, might be okay to show even InfoBiz in 3D. And sometimes it's going to give a better experience and more engaging experience.
So I really like your whole process diagram that you have of exactly what goes into making a story. And obviously, these tools are fantastic, but they're a chunk of that. And I'm wondering, if you think that it's okay that the different steps are sort of necessarily decoupled, or does there have to be some sort of higher level integration in sort of taking the data from the raw form all the way to this?
Yeah. So in fact, that was one of the future work in our viewpoint article. So even none of us are sure about whether having one very unified big tool is better than this small set of tools that needs to work together. And that's the thing that we need to figure out. And it could depend on the types of story that you want to make as well. So unfortunately, I think the safe answer is it depends. Yeah. But you know what's actually interesting there is that the reason why it's difficult to evaluate stories is exactly because of that. Because when people enjoy something, they stay. They just don't leave. They don't read it quickly and then go away. They keep reading, they keep playing. So with the exploration tool, we use this performance metric all the time. If they could do it fast, then that's good. But for the story, if they leave early, you never know whether they left because they didn't like the story or they were not happy. And staying longer doesn't necessarily mean a bad thing in story consumption. And related to that, another reason why it's also challenging to evaluate storytelling is also to be ecologically valid, you cannot ask them to read. Because in real life, people are not asked to read this thing. They come and they decide to read or not and then can leave. So once you ask them to read, it's already a little bit contrived. So you can do this kind of study, like, so technically, New York Times, they probably have all this data, how much time people spend and how much they interacted, etc. Unfortunately, we don't have access to that data and we cannot really collect those data easily. Thank you.